Hello. In the following, we will look at one of the key bones of the forearm, the ulna, which plays a decisive role not only in the stability of the elbow joint but also in enabling the fine movements of the hand. First, let's consider the shaft, the corpus ulnae. This is a slender bone shaft that gradually tapers downward. Its cross-section is triangular, which means it has 3 longitudinal borders, and the surfaces are aligned to these borders. Because of this, the bone can be well oriented even when held in the hand. If we move further down, we reach the pars distalis ulnae. This is a small but cartilage-covered articular end. Here lies the small head, which forms the distal radio-ulnar joint together with the radius, and from here arises the needle-like styloid process. Despite its small size, this part provides important surface landmarks at the wrist. Now let's return to the pars proximalis ulnae, the massive upper end at the elbow. Its characteristic wrench-like shape is formed by the large trochlear notch, which is bounded posteriorly by the huge olecranon and anteriorly by the smaller, forward-projecting coronoid process. Next, let's go through the borders and surfaces of the ulna in order. The anterior edge, the margo anterior ulnae, forms the anterior contour of the shaft. Next to it lies the anterior surface, the facies anterior ulnae. This area is mostly smooth, and the anterior forearm muscles rest upon it. The sharpest border is the margo interosseous ulnae, where the interosseous membrane between the 2 forearm bones is attached. This is an excellent landmark that can be followed along the entire length of the bone. On the inner side runs the facies medialis ulnae, while posteriorly we find the margo posterior ulnae, a ridge that can be palpated clearly along the whole forearm. The large continuous posterior area is the facies posterior ulnae. Here the tendons of the posterior muscle compartment lie, and some of the extensor muscles also take their origin from this surface. Proximally, on the lateral surface, runs a sharp ridge over a shorter distance, the crista supinatoris. This provides the strong attachment site for the supinator muscle. Now let us examine the structures of the ulna in detail, moving from the elbow region distally. At the very top we find the prominent olecranon, a hook-like projection that fits into the posterior fossa of the humerus during extension. The tendon of the triceps attaches here, making this the main lever for elbow extension. In front of it opens the incisura trochlearis, the cartilage-covered trochlear notch. Along its midline runs a longitudinal guiding ridge with a subtle twist. This matches the corresponding groove of the trochlea of the humerus, and like a rail it prevents axial slipping, ensuring a pure hinge movement. The lower lip of the notch is the processus coronoideus. During flexion it fits into the anterior fossa of the humerus. In this way it braces the joint in front. The joint capsule also partly attaches here, which makes its stabilizing role especially important. On the medial margin of the processus coronoideus lies a small but crucial projection, the tuberculum sublime. The anterior bundle of the ulnar collateral ligament attaches here, making this the key point for valgus stability of the elbow. On the lateral side of the trochlear notch there appears a crescent-shaped articular surface, the incisura radialis. Here the head of the radius joins at the proximal radio-ulnar joint. This connection allows the radial head to roll and glide smoothly during pronation and supination. On the same lateral surface there is also a deeper muscular depression, the fossa supinatoria. This houses the supinator muscle, which turns the palm upward, making this part of the proximal ulna the engine cover of forearm rotation. Slightly further down, on the anterior surface of the proximal third, lies a large rough area, the tuberositus ulnae. Here the tendon of the brachialis muscle attaches, transmitting the force of elbow flexion into the ulna. Moving down along the shaft, we eventually reach the distal pole. Here appears a small, rounded articular end, the caput ulnae. Around its side runs a smooth cylindrical arc, the circumferentia articularis capitis ulnae, along which the head rolls in the distal notch of the radius during forearm rotation. On the inferior surface of the head lies an additional articular area, the facies articularis capitis ulnae. This contacts the articular disc of the wrist and ensures smooth, painless movement on the ulnar side of the wrist. The lowermost point is the processus styloideus ulnae, a slender spike on the inner side of the wrist. It serves as an important ligament attachment and is an easily palpable landmark in everyday clinical examination. To summarize, the olecranon, the incisura trochlearis, and the processus coronoideus provide the locking and guiding mechanism of the elbow. The tuberculum sublime and the incisura radialis secure medial stability and the pivot for forearm rotation. The fossa supinatoria and the tuberositis ulnae serve as key muscle attachment sites, and distally, the caput ulnae with its circumferential and inferior articular surfaces, together with the styloid process, ensure the fine mechanics of the wrist. In this way, all the essential structures of the ulna can be clearly understood in sequence from proximal to distal.